So this is 2015 number 1, where I'm assuming you've read the problem already. It's about rainwater that goes in and out of a pipe. So we know that it goes in at R of t. What you should do for this problem is a calculator problem, and if you don't use your calculator very efficiently, it's going to take you twice the amount of time to do this because you have to enter in so many things. The functions are long. So what you want to do here is put R of t into y1. Then we know that the amount going out is d of t, which is given by this big mess. And what I want you to do with this is put this into y2. So the first part of the problem asks how many cubic feet of rainwater flow into the pipe during the 8-hour time interval. So they want to know how much total does rainwater goes in. Well, so whenever they ask for amount, how many, something like that, that should tell you that you want the integral of the rate. Because that's saying how much total rainwater goes in. So that's accumulation. So part A is from 0 to 8, because that's how long we want, of 20 sine t squared over 35 dt. Now, what you have hopefully done, you've put that into y1. So instead of having to enter this in every time you do something, you can on your calculator, you get the integral, and then what you do in here is you're going to access y1. So what you do is you go to vars, find the vars button, and then you scroll over to y vars, and then you hit function, and then y1, and then here, and then you would do dt. So that will already be done for you. You don't have to enter it in. And of course, double check to make sure that the functions you've entered in are correct. But as long as you've entered them in correctly, this will be so much easier. Okay, so you end up getting 76.570 cubic feet. Okay. And actually, the scoring guidelines don't have units, which is kind of interesting. Okay. So part A. Part B says, is the amount of water in the pipe increasing or decreasing at time t equals 3? Give a reason. So you need to know, is the total amount of water is the rate of the water, the total rate, getting bigger or getting smaller? So you have to consider the fact that water is going in and water is going out. So what you would do is you would say, well, the water going in is R of 3, and I'm going to subtract the amount of water going out, which is D of 3. So now on your calculator, you do the same thing with the vars. So you would do vars, y vars, function y1, and what you do is you do y1 of 3, and then you do the same thing, the process again, and you subtract y2 of 3. Now make sure you have the parentheses in it. So that's telling you, you're telling the calculator that you want to evaluate that function at t, or x equals 3. So what you end up getting is negative 0.31362. So this is less than 0. So this is a negative rate. So you can say, since the total rate of water flowing into the pipe is negative at, make sure you say at t equals 3, then the amount of water is decreasing. At t equals 3. Okay, so parts A and B are pretty straightforward, and you really just need a little sentence for the reason there. Part C is much more involved. So part C is the big part of this question. The part C is what will take you the longest time. So the first part of the question, well, it says, and of course it's the shortest question, at what time t, where t is between 0 and 8, is the amount of water in the pipe at a minimum? So in our heads, minimum, it means that we need to have a derivative and set it equal to 0. So a minimum means derivative and set it equal to 0. But for us, we're basically already given the derivatives, because derivative in your head with these word problems should also mean rate. And so we're told the rate that the water flows in and the water flows out. So, because this is asking for the minimum amount. So minimum amount would mean the first derivative of the amount is the rate, and so we set that equal to 0. So our derivative for this problem is r of t minus d of t. So we want when r of t minus d of t equals 0. So luckily for us, we have these in the calculator. So you can either graph them, you can just go to graph and hit graph, you already have them in y1 and y2, and then just find where they intersect, because you would just set them equal, or you can go to y3, so in y3, and I actually think this is better because you're going to need it for you can use it for the rest of the question. So in y3, you go to, again, vars, y-vars, function, and then you do y1, and then, so then you'll have y1, and then you can go back, and so you do y1 minus, and then again, vars, y-vars, y2. So y3 should look like this. Then this is really nice because you can just graph this. You can turn off y1 and y2, and you do that by hitting enter on the over the equal sign. So you can turn off y1 and y2 and just graph y3 and find the 0. So when you do that, the 0, or the intersection point if you do it the other way, is 3.27165884, and if you you quit, then you can hit you can just hit the X button, the X, not the green X, but the X that's at the top of your keyboard. So you can hit X and then store, and then I don't know, A, whatever. You can store it as whatever you want. I'm going to store it as A. So, because it will remember the most recent X value that you found. So, okay. So we did that. So that's where there's a minimum. And we can see that that is actually, it's between 0 and 8. So the justification part here is they want you to justify that that's a minimum. It's the minimum on the interval. Now, every word problem on the AP test, if they ask you for a minimum or maximum, you have to ask yourself, is this on an interval? And if the answer is yes, then you have to use the extreme value theorem. You have to use the extreme value theorem, which says I need to test the endpoints of the interval and the minimum or maximum, in this case minimum, that we found on the interval. Now, unfortunately, you can't just graph this and then look at it and see. I mean, first of all, if you look at the graph, remember that's the derivative, not the function. So your justification for this is going to be your use of the extreme value theorem. And so what you can do is, you don't have to necessarily say, a whole lot at the end, you're going to use the extreme value theorem. Now, the extreme value theorem says that I plug in these values into the function, into f, into g, whatever you're calling it. We don't have that, right? We have the derivatives. So what do I need to do? I need to do it using the integral of the derivative. So if I want to find at t equals 0, that's going to be from 0 to 0, which is kind of, you know, you're going to get 0, of d of t minus r of t, oh sorry, oops, reversed, r of t minus d of t, dt. This will give you the amount at 0, or over from 0 to 0. What we have to remember is that the problem actually tells us that there's already 30 cubic feet of water in the pipe when at t equals 0, so I have to add 30. So when you integrate from 0 to 0, you're going to get 0, then plus 30 is 30. Okay, at t equals, now here's our value that we found. So that's going to be from the amount from 0 to that number. And the great thing is that if you've done the y3 equals y1 minus y2, you can literally just put into your calculator y1 minus y2 into your integral. So y1 minus y2. It's really nice. Plus 30. This will give you 27.9645, blah, 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 blah. Okay, and then the last part of the interval at t equals 8. You've got from 0 to 8. If you can do y1 minus y2. It's so nice to do it this way, and it makes mistakes a lot less frequent. Plus 30, and you get 48.5436868. So you can see that the smallest value of water is going to be at that minimum that we found. You can say the amount of water over 0 is at a minimum at t equals 3.272 hours. Since this is the last part of that question, I can round it to 3 decimal places. So that is part B, or part C. And then part D is, it's a long question, but it's actually a pretty straightforward question. It says the pipe can hold 50 cubic feet of water before overflowing. Now, so then they say for t is greater than 8, water continues to flow in and out at the same rates that we've already been using. Write, but do not solve, an equation involving one or more integrals that gives the time w when the pipe begins to overflow. So if we know it starts overflowing at 50, so we know that that's the amount, 50 is the amount that we want to find when is there 50 cubic feet. Well, we know that we measure the amount of cubic feet by that integral of RT minus DT, and then plus 30. So it's 50 equals, we don't know what time, they tell us to use W as your time. So from 0 to W, so we know at W at that point is where it would overflow. And that's it. That's all they want for Part D. So that is 2015 question 1.